So today we start our study of scatter plots. And scatter plots really are just a pretty way to display data. Okay? And so a scatter plot's generally going to have an x-axis and a y-axis, and then it's going to have points all throughout it. Okay? And one big word that you'll see in scatter plots is going to be correlation. Okay? And what correlation means is things that affect each other. So, does who your father is affect how tall you end up being? Yeah, I mean, who your dad is affects your height. If you have a short father, chances are you're going to be short unless you have a really tall mother. Okay? So the height of your parents affects your height. Right? Are there outliers? Yes. Outlier is people that doesn't make sense. Like I've seen two short parents and a really tall dad. And I've seen two really tall parents and a little short child who's like, fully grown, but they still end up being short. So there are outliers. But for the most part, the height of your parents correlates to your height, right? Here's another one. The amount of time, your attendance in school correlates to your grade in school, in your classes. The more classes you come to, the higher your grade will be. The less classes you come to, the lower your grade will be, right? So those correlate, don't they? There are some things that don't correlate. Does your hair color have anything to do with your shoe size? No, so they do not correlate. One does not affect the other, okay? Now, when we have a correlation, we use scatter plots to represent it. This right here is a positive correlation. The reason it's positive is because you can see the data is moving up and to the right. Okay? Now, we read from left to right, and so I don't read this graph saying it's going down because that's right to left. From left to right, the data is moving in which direction? So look, the more hours a student spends studying, the higher their grade will be, right? If a student spent 1 hour studying, he made an 8 on the test. If he spent 2 hours studying, he made a 30 on the test. And so on and so forth. His time studying directly affect his grade, right? And so that is a positive correlation. Okay, now here's what a negative correlation look like. Okay, you can see now the data is moving which direction? Down. And it clearly has a pattern, right? So when it's moving down, it is a negative correlation. Right? Right. And so let's imagine that the x-axis is number of years that you smoke. Okay? And the y-axis, let's say, is how old you are when you die. Right? So if you smoked for 0 years, you're going to grow to be nice and old, aren't you? And the more you smoke, the quicker you what? Die. So that would be a good example of a negative correlation. Right? Okay, so now let's look at what a no correlation looks like. No correlation is like what I said to you. Let's say along here, I put your hair color. And along the y-axis, I put your height. Your hair color does not affect your height, does it? And so the data is just going to be scattered all over the page without it making any sense. And so that's why it's called no correlation, because one variable does not affect the other. Your shoe color does not affect your height in any way. Okay? Now, this is nonlinear correlation. You can see that it has a correlation, doesn't it? Yes. But the correlation is not a straight line, right? If you come back here, it's a straight line, isn't it? Yes. In a positive direction. Here it's a straight line in a negative direction. This one correlates it just doesn't correlate in a straight line, does it? It's more like a parabola, isn't it? Okay? So those are your 4 types of scatter plots, right? So now let's look at this one. What kind of correlation does that have? Positive correlation. It's moving upward, right? Okay, now, here's what I want you also to do. I want you to look at this line right here. Whenever we have a set of data, we like to draw a line of best fit, okay? Now, the goal is to get it where there's the same number of points above the line as below the line, and the line should have the same slope as the data. So where my line is not a good line of best fit because all the data is below it, right? Mm-hmm. And now it's still not a good line of best fit because all the data is what? Above it. Look at this. Now I have the same number of points above and below it, but it doesn't match the slope of the blue points, does it? Right. So that's also a bad line of best fit. Okay, because you can see the blue line's moving like this, and the red line's too steep, isn't it? Okay. But let's say I take this red line and I move it like that. Now I have about the same number of points below the red line as above it, and the red line matches the slope of the data, doesn't it? So that is a good line of best fit. Okay? Look at this one. What kind of correlation does this graph have? Negative. Negative. And see how the points are real tight? So it means it's a good correlation. Now this one has a negative correlation here, but do you see how they're more spread out? Yes. So it has a negative correlation, but it's not as tight of a correlation. It's not as good of a correlation. Okay, look at this one right here. This one has a negative correlation, but then it also has an outlier. Say outlier. Outlier. Okay, so if I were to make a scatter plot of the heights of all the girls in the school, okay, it's going to look something like this. But then there is going to be some girl that's way shorter than everybody else. And then there will also be some girl that's way taller than everybody else. So these two values are called what? Outliers. You will get outliers. Your data will have a trend, but there will be people who are outside of that trend. Okay? So like this class would have a trend for your grades. All about the same. But then there's going to be some of you in here that are, your grade's way lower than most people's. And there's going to be some folks in here that your grade's way higher than most folks. You see what I'm saying? If we did a trend line of the amount of time y'all spend on Khan Academy, it's going to all be about the same. But then there's a few of you in here that spend a lot more time, and your grade is also correlated to that. And there's some of you who spend very little time, and your grade has gone down as a result as well. You see what I'm saying? So some of you in here are outliers. What you'd like is you'd like to always be a good outlier, right? Not a bad one. Okay, look at this one. This is not a positive or a negative correlation. We call this zero. Not as in there's not a correlation. There is. It's just it's flat, right? But then there's also a what? Outlier. Look right here. What would this one be? Nonlinear correlation. Okay, what's this one? This is a positive correlation. Now, this one you can't tell it, but listen, this is a positive correlation. It is moving up. But don't you think this one is a better positive correlation? Yes. This one's moving up, but the data is really scattered, right? Yes. So it's not a very good, they don't correlate well. The data here correlates really well, right? Okay, so let's look at this one. What kind of correlation does this have? Positive, right? And look at this one. Nonlinear correlation. Okay, here's another one, right? What kind of correlation does that have? Negative, because it's moving down. Okay, so now that you know all that, these are the 3 activities in Khan Academy that cover scatter plots. Okay, so your goal is to be able to get 5 or 3 in a row on each. If it says just get 1, you need to miss the first one and then get 3 or 5.